Okay, so let's understand the problem statement. If you closely see, uh, you are a professional robber planning to rob houses along the street. Each house has certain amount of money stashed. The only constraint stopping you to robbing each of them is that adjacent houses are having security connected systems so that it automatically alert so that you cannot rob from two adjacent houses. So that's what the constraint is trying to say. So let me explain through iPad. So the problem statement says, so you will be given houses in the form of an array. Okay, so this is houses. So assume that 1, 2, 3, 1, and which are represented as indexes 0, 1, 2, 3. So there is a house robber. He want to rob the houses, but each house profit is mentioned in the respective index. He wanted to gain the maximum profit, but the constraint is this is a constraint he has, cannot rob from adjacent houses. So this is the constraint he has. So let's say how it works. You have one, two, three, one, right? One, two, three, one. Let's say there are multiple possible ways to do this. So let's say how we can do it. For example, the thief has chosen house one. Then he cannot choose adjacent. How he cannot choose this one? So obviously he move on to house two. If he choose house 2, he cannot choose house 4. So that here the maximum profit he could gain is 4. So let's move further. Let's see other possibility. 1, 2, 3, 1, right? Let's say the robber has chosen house 2. Then he cannot choose house 1, definitely. And he can't choose house 3 also because he chosen house 2. So then he can go with house 4. Here the profit he could gain is 3, and that's how. So he has to start from. Okay, is it? That's how he has to start from either one or either house one or house two. If he start from house one, this is the profit he could get. If he start from house two, this is the profit he could get. So the max profit he has gained is 4. So that the answer is 4. So did you understand the problem statement?
Yes.
Okay. Let me see. Is it disturbing or voice is clear? How is it?
Yeah, it's clear.
It's clear, Srinu, no background noise.
Recording started. Right?
Yeah, yeah, recording now started. Okay, so let's move on. So how can we solve it, right? So let's move on. Let me walk through one more input. Okay, it is 27931. Okay. You have 27931. Okay. So in this
Yes.
case, how we can choose? For example, house one.
We are not able to see that iPad.
Yeah, yeah, yeah. So 27931. So 291. So which is going to be 12. Other possibility could be. Uh, so let me draw other possibility. So if you choose one, then you can choose this one. So this is going to be 10. So that max out of it is 12. So that's how it works. So let's move on. How do you solve it, right? So how do you solve it? So it's a, let me take the second input. We have input as 27931. Okay. 0, 1, 2, 3, 4. So let's go with let's go with let's go with recursive solution. So as it is top down approach, as it is a top down approach, so I must start with the last house, which is representing as index 4. So let's say I am at index 4. So uh, let's say how do you do it. So for example, if I include the profit of index 4, it means if I rob house 4, it means I robbed house 4. If I rob house 4, then I should take that house 4 value. Then I cannot choose house 3. I can choose previous to that, right? So it means I cannot choose I minus 1 house, but I can choose I minus 2 house. Then definitely which is going to be I2. Is it clear? This point is clear. This point is clear.
Yes.
So because this is what the constraint, right? If I choose this house, I cannot choose this house because adjacent houses cannot be chosen. So that if I choose current house, then I must choose previous to previous house. So which is going to be I minus 2. So that as I choose in current house, I consider the current profit. Then I move on to the 9. Okay. So let's move further. Let's say I am choosing I2. Okay, so I am choosing I2. It means I am here. I am choosing I2. So if I choose I2, so I can consider the current profit plus as I choose an I2, I cannot choose I1, so that I directly move on to I0. Okay, so let's move on to I0. So I0. Now this is where you move further, buddy? Can you move further? You can't move further, right? So from I0 you cannot move further. Then it's time for you to get into the base case. So it means I0 means what does it mean? I0 means what does it mean?
It's starting index.
It's starting index. With respect to problem statement, I0 means what does it mean? Let's say you don't have any other let's say you don't have all these problems and you have only I0. So what does it mean?
Base.
Base. Okay. Can you come up as a more clarified way? For example, you have only 2. So this is what I0, right?
Yeah.
So what does it mean?
Last element.
When you are thinking about dynamic problem, right, you always think about current problem. So current problem is I0. It means uh, to your brain, you should feel that there is only one element. There is only one element in a given input. That's what you should think. So there is only one element in the given input. So what does it mean? So you have with only one house, right? I0
Yeah.
means what? You have with only one house. So don't think about all other parent problems. You only think about current problem. With respect to current problem, it means you have only one house. Okay, so I have only one house. Then I don't have any option, right? I can directly return that value, na?
Yes.
Yes or nobody? So if I have only one house, I don't have any option, so that I can directly return 2. So that obviously what this I0 will return. Okay, so what this I0 will return? It will just return its value. So the value of I0, which is 2, so it will just return 2. So the 2 will be added here. So when I choose an I2, then I must choose I0. So when I choose I0, I just get value 2. So that for I2, if I choose I2, I get value as 9 plus 2, so which is going to be 11. So which is going to be 11. So let me mark here itself. So which is going to be 11. Let's move on. I don't choose I2. It means, let's move on. This is how you derive it. So I'm not making it as you already know. As you already know recursion, so that I'm going from top down, but you solve it from bottom up. Okay, so I am not choosing I2. So if I am not choosing I2, then I can go to I1, right? Yes or nobody? If I don't
Yeah.
choose this, I can go to I1, right? I can choose I1. So that what I can do, if I don't choose I2, so then there is no profit from I2. So that I don't choose I2. So obviously there is no profit from I2. So that I can blindly go to I1. Okay, so uh, now, yeah. So obviously, as you don't choose, it is 0 plus. So I1. So as you don't choose I2, so that you can't consider the I2 value, so which is 0 plus I1. Now tell me. So now tell me I1, right? How do you feel it? So I what do you mean by I1? What do you mean by I1? Can you tell me what do you mean by I1? Assume that you don't have any other houses, so you have only I1. So what do you mean by I1?
Rob that house I1 because there are no adjacent houses present.
No, I1 means there are two houses, right? 0, 1. I1 means index 0, index 1. So there are two houses. It means, for example, 2, 7. So you have index 0, index 1. So there are two houses, right? I1 means, yes or no?
Yeah, we are selecting I1 because we cannot rob the house which is adjacent to I1, which is I0.
What if, what if my 3, 1? In this case, how do you do that? Do you select I1 or I0?
I0,
Why?
because we'll get the highest profit there only.
Correct. So it means if you have only two houses, so what do you mean by I1? If you have only two houses, so if you have two houses, what do? Whichever is maximum, you will pick up, right? So when you have two houses, either you can pick I0 or I1. So you cannot pick both, right? So you cannot pick both. So you can pick one of out of two must be chosen. So which one you will choose? Definitely whichever is having maximum profit, right? So whichever is having maximum profit. So what you do when I equal to 1, so you must and should understand that whatever is maximum, so whether it is assume that it is nums, okay, so this is nums, so whichever is max, so nums of 0 or nums of 1. So it means you have only I1 means you have only two elements. So when you have two elements, if I choose I1, you can't go backward, right? So you can't go to minus 1. Generally, with common sense, what do you think? So when you have two houses, you can choose one out of them. So that obviously you can choose maximum out of it. The max value is 7. So that this I1 will return 7. Now, now let's understand here. You are at you are at I2. If you include I2, you can go to I0. Then as you include I2, so you consider the I2 value 9 plus you will try to figure out the value of I0, which is written as 2, so that you get 11. If I don't include I2, then I can directly go to I1, so that with I1, so you can get the value as 7. Now which one you will consider with respect to I2? Which one you will consider, 11 or 7?
11.
Right? Why?
Higher value.
Higher value. So it means what do? From a current problem, you will derive two sub problems. One is include, other is exclude, right? So one is include, other is exclude. You will derive two sub problems, and each sub problem will return value. So you will consider max of those, right? Yes or nobody?
Yes.
Yes.
So you will return max of 11 comma 7, so which is going to be 11. So obviously you will definitely go with 11, so that 11 will be coming here. Got it? So from I4, if you closely see, this is what we did. So first I included I4, so that I went to I2. So if I included I2, then I went to I0. So these four sums I am able to derive, but obviously I got the value as 1 plus 11, so which is going to be 12. Perfect. So we have seen
But
one
Shrinu,
possibility.
one question here. From I2 to we went to I0 because the value was higher. Second
No, no, no,
thing
no, no.
was
No, no, no. We didn't went to I0 not because of value was higher. So when you are I2, let's say this is how it is, right? So when you are at I2, So when you are at I2, so you have two options. I can include I2, or let me take this. So when you are at I2, so I have two options. I can include I2 or I can exclude I2. If I include I2, then I will go to I0. If I exclude I2, then I will go to I1. As you are including I2, you take the profit of I2, 9, then I will move on to I0. So I0 will return 2. If I exclude I2, then I cannot take the profit of I2, so that it is 0 plus I1. With I1, the profit you gain is 7. That's how you get it, right?
Okay.
So
Okay.
it's
Got it.
not
Got it.
it's not because of it is a higher value. So we just went on. We don't know what is the value it has, whether it is include or
Mm.
exclude. Okay. Now let's move on. What we did from I4, we included I4 so that we went to I2. Now let's move on to other possibility. I don't include I4. Then I4 profit is 0. It means, what does it mean? So you are not considering I4. You are not considering I4. Then obviously you will go to previous one only, right? So you can consider previous one, right? So definitely you will move on to previous one, so which is going to be I3. Are you understanding what I'm trying to say?
Yes.
Yes.
Now, let's move on. Now I need to store this result here, so that I didn't derive this problem. So that let me go further. So let's move on. I am trying to have. I am trying to. Okay. So now again I have two possibilities. I can include or I can exclude. So if I include, so definitely I will move on to what? I can take the current profit. So the current profit of I3, so which is 3. So take 3. So definitely I need to take 3. So 3 plus, as I included, as I included current I3, so I cannot include this one. So definitely I should move on to its previous to previous. So current index minus 2. So I will move on to I1. Perfect. So that I will move on to I1. As I exclude, if I don't exclude, so it is 0 plus, I can just move on to previous index I2. So let's move further. So if I include I2, then I can take the I2 profit. So 9 plus, definitely I will move on to the previous one. So I0. If I exclude, it is going to be I1. So I'm just directly writing it. So I0, sorry. So let's take I0 value is 2, so that just take 2. With I1 we got the value as 7, so let's take 7. So 9 plus 2, so which is going to be 11. So that this is going to return value 11. Okay, so 11 will be stored here. Then if you come in this direction, so I3, so if I include I3, then I will move on to I1. With I1 we got the profit as 7, so that 7 will be added, so this will return 10. Out of these two values, 11 is the actual output, so that let's take 11 here. So 11 is the actual output, so you will consider 11 here, so that if you closely see, this will return 11. So if I, with I4, if I go with inclusion of I4, I got value 12. Exclusion of I4, I got value 11, so that obviously you will consider max of 12 comma 11, so which is going to be 12. So you will simply return 12. Got it, buddy?
Yes.
Yes.
Okay, so let me write the. So what is the time complexity here? Tell me.
2 power n.
To the point.
So what are we trying to do? So this is my time complexity. So definitely, you are trying to see all possibilities. So which is going to be 2 to the power of n, because every n element will have two possibilities, and you are trying to explore everything, right? So you are trying to explore everything, so that obviously the time complexity is going to be 2 to the power n. Somehow, whatever I am typing, right, which is giving a lot of delay on the screen, but are you comfortable with it, or can I reconnect?
That's okay, but we also see the delay.
Yeah, we also see the delay. Yeah.
Is that fine, or
That's okay.
I didn't shut down the laptop since last 2 days, so that which is why it is causing delay. Okay.
It's
So
okay.
Yeah, fine. So what is the space complexity?
Order of order of n.
Okay, let me reconnect this iPad at least. Yeah, now it is no delay. Okay. So what is the space complexity you could see? It is order of n, right? So at any point in time, only n stack frames get active. So that obviously which is going to be order of n. Okay. So now let's write the logic. Let's write the brute force logic. Then we can implement furthermore. So what is our job? So definitely this is my method. So it needs my given input nums, and it also needs the index, right? Then what are the base cases? Can you tell me what are the base cases? What are the base cases you could consider out of this diagram?
I should be
No, base cases means what are the base results. So when do you sure that this is the result? Base
when we
case
have
means when do you show that this is result? This is the result. You should go with it.
when I equal to 1.
Okay. So when I equal
Max
to
of
one,
gate positive values.
then what is other case? Okay. So you found out one base case when I equal to one. Okay. So what is other case?
The other one is only we have one house.
Yeah. So other case is zero, right? So when I
Yeah,
equal zero, you will blindly return that value. But when I equal to one, you blindly return which is maximum out of these two values, right?
Correct.
So
Yeah.
so that's why those two are the base cases. So that so one thing is if index equals zero, laptop itself went down. It's not the problem with iPad. Okay. It's late today. Probably I will restart after this session.
If you reconnect the internet, it will work, I think.
No, it's not issue with the internet. Uh,
Okay.
it's an issue with the laptop, so it was overloaded. Okay. So this is clear, right? Base case is clear, right? So when I is 0, so you just return its value. When I is 1, so you return whichever is maximum out of these two. Now what is your job now? So include current house. So if you want to include current house, then what you are trying to do, tell me. If I want to include current house, what should I do?
I will draw it.
What are we doing here? Can you tell me the relation now? So I am including the current house. I am including the current house, right? So this is include. So I am including the current house. So when you include the current house, so what are you trying to do then?
Nums of I, nums of I plus, we will add that house.
We will try to move on to I minus 2, right? Yes
Yeah.
or no? But we don't know the
Yeah.
subproblem results, right? So we don't know subproblem result, then we will derive it again. So that's how the recursion will work. Recursion will take care of it. So let's move on. So it means if I include current house, it means if I include current house, it means which is represented as current index, then I can draw from index minus 2, correct?
Yes.
Okay, my voice is raising. Okay. So index minus 2. Now what is other case? I also see the I also see the exclude current house. Okay. So if I
No
exclude,
nums of index, only
yes,
raw of nums of index minus 1.
perfect. So there you don't take the current house profit, then just go with index minus one. Now,
Yeah,
what is your job? So you will get values from both of the cases, so that finally you will return whichever is maximum,
max both. Yeah.
whether I include or I exclude. That's it. So finally you will return.
In the bracket issue, line number 19.
Yeah. So what do you do? So you will just call rob method with nums, comma, nums dot length minus one. That's it. So it will take care of. It will just do that. So fine. So but this is purely brute force, right? So then we need to optimize it. So to optimize it, first we will understand the recursion diagram. So without taking values, let me take somewhat higher input so that you feel there is a duplicate case. There are duplicate problems. Okay, so first I am at I7. So from I7 I can reach to where, buddy? If I include or exclude, I can go to I2. Sorry, I5. If I include, I can go to I5. If I exclude, I can go to I6. Similarly, let's move further. Include, exclude. If I include, I can go to I3. If I exclude, I can go to I4. There is a delay, so let's see. I1, I2, then I0, and I1. Uh, I'm not getting into other cases, but if you closely see, even if you draw all these, but let's pause here. So this is a simple diagram. I just took it. I'm not taking other cases, but I just to you see here how many sub problems repeated. So you already solved I3 here, I2 here, but you are trying to solve again here and here, here and here and here. So similarly, if you extend this other I6 pattern, right, definitely you will understand that there are a lot of repeating problems. Now, how do you find out uniqueness of the repeated problem? Right, so how do you find out uniqueness of the repeated problem? If you see I I3 you solved and I2 also you solved, but what are you trying to do? So you are trying to solve again and again. So here I solved, here I also solved, here I also solved. So how do you identify the uniqueness of the repeated problem? In this problem, how are you identifying uniqueness of the repeated problem? Tell me, buddy.
Because here in the diagram, it's easy to see that I3 is being repeated in multiple nodes.
Mm. Yes. So even if you closely see, here you solved, again you are trying to solve here. Okay.
Correct.
Uh, so yeah. So now, what do you understand? How do you how you should see is when how do you find out a uniqueness of the repeated problem is based on what you are dividing the subproblem. Based on what criteria you are dividing the subproblem. From
Yeah.
I7 you went to I5 and I6, right? It means you purely dividing based on the index number only, na? Yes or no?
Yes.
Correct.
There are no other
Yep.
parameters. So that is only the parameter which is helping me to divide the main problem into possible subproblems. Definitely the duplication of problems is based on the index. As it is
Yep.
based on the index, then I should identify, I should cache that result. So definitely what should I take? I need to take the definitely I need to take what? A temp memory. So let me consider a temp memory. so that I'm just taking temp memory. It is index, right? So it's a single dimensional array because I need to store all the indexes. So it is going to be my DP. And what is the size of my DP now? Tell me please. What is the size of my DP now? Tell me please. Ajay, Akash.
Original array size plus 1.
Plus 1 needed. If you closely see, how are you deriving the problem?
Okay, so the max of both Rob and Skipper.
Oh, okay, okay. Forget about the result. I'm asking about the state, right? State. So we need to store the subproblem result. To store the subproblem results, where are you starting the problem?
I4. Okay.
So I4 means the maximum size of this index is going to be n, right? So it means if you consider
Okay.
n equal nums dot length, so that is your max index, right? Correct, na?
Yeah.
No confusion, right? So this is your state. Okay, so this is your state now. So you took DP array. So now let's move on. So I will quickly write it. What is 2927931? So what are we doing now? So let's move further. You have 0, 0, 1, 2, 3, 4. So there are 4 elements. Initially in my DP, so I will make this is my DP. So initially what I do, so I will make everything is -1. Perfect. Everything is -1. Let's keep everything as is so that following the pattern becomes usual. Following the pattern becomes simple for you. Okay, so as it is a recursion, so we will have base cases everything as is. Okay, so now first we will start from I4 and we will see is I4 is derived. No, it is not derived because the value is -1. At I4 you have at the DP of 4 which is value is -1, so that you will try to include it. So including means 1 plus you will try to go with I2. So let's go to I2. Let's go to I2 so that value is not derived. So that what you do, you will try to include the I2 value. So that I2 value is 9. 9 plus, so this is 0, 1, 2, 3, 4, right? So this is our nums array. Okay, so you include I2. So as you include I2, then you will move on to I0. Now when it is I0, then there are one way for I0 is not solved, and you also know that I0 is the base case. Yes or nobody? I0 is the base case. So as I0 is base case, you can directly return I0 value, so which is 2, so that it will return 11. Okay, now it is returning 11. Now it's move on to it. You didn't solve I2 problem at all, so you just consider including, then let's consider exclude, then you will find out a uh, problem. Okay, so exclude, you will reach to I1. So when it is I1, so you will consider max of these two, so definitely you will return 7. Okay, now you have include and exclude from I2, so that definitely you can consider max of these two. So max of these two 11 comma 7, so that that 11 obviously which is going to return 11, so that that 11 will be stored into I2. So whatever result you gain from the problem, you will store that result into I2. Now it means from I4 you include it, so that you get the I2 profit, so the total profit equal 12. Now let's move on to exclude case. So if you go exclude, and you will move on to I3. Now let's see here, is I3 solved? No, it's not solved. So that what you do, first you try including, so the I3 value is 3 plus, you try to include it. So if you include it, then you will move on to I1. If you exclude it, you will move on to I2. Now if you closely see, I1 definitely it will return 7 because max of these two. Uh, then when it comes to I2, you already solved I2, right? So you already solved I2 because value is not -1. So you don't solve it again, so you can blindly return 11. Perfect. So now you have here 10, here 11. So the maximum out of it equal to 11. So the first you store 11 here and you return to the top. Now if you closely see from I4, include you got 12, exclude you got 11, so that 12 will be returned to us. So 12 is the answer, so that at I4 you will store the 12. So finally you will just return dp of length minus 1, so that 12 is your answer. You understood? Understood?
Yes, Srinu.
So now what is the time complexity here?
Linear.
Why it is linear? Though it is divided into two subproblems, but why it became linear?
Because the already solved problems, we are not trying to resolve it again.
Yes.
For
So
example, in
that's
I2,
only
once
the
it's solved, we just use it. Yeah.
correct. Correct. So that's only the difference. Earlier we just solved the. If you see, we just solved I2 again. So it means though here also we are trying to divide the subproblem into two subproblem. Main problem we are dividing into two subproblems. But earlier we solved. Earlier, if you closely see, we solved again. So we solved again. But in this case, what are we trying to do? We are not solving it again. So we are trying to get it from the cache. So this is only the difference. So that's why it's not going to be exponential. So which is going to be n into 2. So which is going to be n. And finally, the space complexity, how much? What is the space complexity?
It's order of n only we are taking.
So order of n for stack and order of n for dp, right? So dp array. Now, if you closely understand, so can you tell me the state now? So now this is the pattern, right? So when you try to solve the dp problem, first you will consider what is the state of your recursive call. Uh, then what do? You will also consider what is the recurrence relationship. So what is the recurrence relationship? So uh, what is the state of my recursive call? Tell me please. Tell me, buddy.
When you say state, does it mean the base case, Srinu?
Not base case. What are you trying to pass to this recursive call?
Okay, recursive call. Okay. The nums array. Uh,
Okay. State, generally you talk about state means whichever is frequently changing. So nums array won't
hmm,
change, right? So you can ignore that. Okay.
okay.
Yeah. What is frequently changing in this recursive call?
What to include, what not to, what to exclude.
So
That
what do you
index.
think is changing? Not the result I am talking about. In the
Like,
recursive call, you have parameters, right? In those
yeah.
Yeah, the
parameters,
index.
one is index. Okay, what is other? I didn't mention here, but you should identify what is other is changing.
Inclusion value, exclusion value.
That is a result, right?
Okay, that's the result. Yeah.
One we are skipping.
No, how do you get this I2? Here you
We are
got I2, right? How do you get this I2?
we are skipping I3.
No, no. How do you get? You didn't solve I2, right? You got the I2 value. How do you
Okay.
get the I2 value, and how do you know that it is already solved here?
Okay, that
We are
current
caching.
DP array,
DP, right? So definitely
current
you
DP array.
must and should have a DP. So these two are the changing parameters within your memoization solution, right? Correct, na?
Yes.
So what is the recurrence relation here? So it means if I wanted to find DP of current index, then what is the recurrence relationship?
Max of
Okay, max of.
DP of
No, no,
index.
no. That is
Max of
don't get
inclusion and
into don't
exclusion.
get into memoization. What is it?
Okay.
Tabulation. So just think in
Tabulation.
only recursive purpose. So it means
Max.
if I want to get DP of index, so generally if I go detailed way. So first one is you are trying to include, right? So if you want to include, so what you do? You will take the nums of index
Yeah.
and plus you will move on to index minus 2, correct,
Hmm.
comma
Correct.
dp. Or if I want to exclude, what you are trying to do, so you will directly go on to index minus 1 into dp. So now my dp of index is going to be what?
We need nums also, right? In the
Max.
exclude also.
Yeah, I'm not adding everything in the
Max
method.
of max of include comma exclude.
Yeah. So include comma exclude.
Yeah.
That's it. This is your recurrence relation, right? Correct.
Hmm.
So if I
Yes.
write it as a single formula, so index equal you can write as a, you can include those two into single line, right? So I am not writing, so you can include this line comma, you can include this line, so this is going to be your recurrence relationship. Okay, now what is the base case, tell me?
dp of 0
Yeah, so if
is
I
equal
equal to
to
0, then you just return nums of 0, right?
Yeah.
yeah,
If I equal to 1, then you return
max
max
of
of,
both.
yeah, 1 comma 2. Okay, so nums of 1 comma nums of 2. Got
0
it?
comma 1, right?
Yeah. Return max of nums of 0 or nums of 2. Okay. Let's move on. Now what is changing in this code, tell me? What is changing in this code?
We just need to add
First
dp.
of all, I will just introduce a new variable, so which is dp, so which is nums dot length. Okay. First, let me copy this input. Okay. Okay. So one thing for sure. First, I will consider dp. Then now, if you understand here, so I'm introducing new variable dp. And there is no change in base case, so that there is a new variable called as dp. As it is a recursive call, so there is no change in base cases. I'll keep it same. Now let's see here. If my dp of current index, if it is not equal to minus 1, it means which is already solved. So what is your job? So you can directly return dp of index. Then what do you do next? Whenever you are trying to include, you just go on to the dp, you include dp. Whenever you are trying to exclude, you will also include dp. Now this is my dp of current index, so you will directly say whichever is the maximum out of it, so you will just return dp of index. Simple. So I am just introducing a new state called dp, that's it. So this will, there is no change in the code which I did earlier. I'm just keep on updating it. So what is the mistake we had in? What is the mistake? Tell me, bro. It is giving 0. Everywhere it is giving 0. With by seeing, by looking at the code. So what is the mistake? Tell me.
dp of index minus 1 that we have to return.
No, even if you return everything, or let me do one thing.
No, that is correct because last value only we have to return.
String of dp. What I'll do, I'll just return dp of. I know the answer, but if you see this, you will get it. But tell me what is the mistake we are doing. So what is my dp is having?
Okay.
Oh, we need to fill it with minus 1.
With minus 1, or we can directly check in the 18th not null condition, right?
Huh?
Because in the 18th you're checking with minus 1, right? If you check it with the null condition, it will work.
But null it won't be there, right? So it is a primitive type. You always
Undefined.
have previous default value as 0. The only mistake we are
Okay.
doing is we are considering it, we are checking dp of index as -1, but we are not updating the dp index with -1 initially. So we are not defining the state of a unsolved problem, right? So first we fill dp with -1, then it will work. So when initially it is 0, right? So -1 not equal to 0, so that obviously it is always returning 0. So that for every problem you will get the value as 0. So that's a mistake.
So we can use the integer type closure, right? Not the wrapper.
Then you should use not null, right? Not equal to null, right? Anyhow, you can't avoid that not condition, no? Instead of -1, you will apply not null.
Mm.
Okay, now fine. So now we were able to derive somehow memoization solution. So let's move on how to derive the tabulation. Alright, today is the session. We will go little slow, but from next session onwards, it doesn't. I don't explain everything. I will just write. I will explain the recursive approach. Then memoization and tabulation will be little quick, very quick. Okay. So now, if you want to go with the tabulation, so what do you need to know? You should start from base, right? Yes or nobody?
Yeah.
So it means tabulation is nothing but bottom up, right? Okay, so bottom up. So when you go with tabulation, right, what are the base cases you are returning on memoization? Those are the sub problems of tabulation. Somebody is trying to join.
No, there is no one.
I got a hint message.
Okay.
Okay, so let's move on. Okay, so what are the sub problems of memoization? Those are the results, base results of your tabulation. Okay, so that's how you should go. The laptop went very slow, man. Please bear me today. Okay, so let's move on. This is not at all. Okay. So if you closely see, what are the sub problems you see on memoization? What are the base cases on memoization? So here also, one thing for sure, even in tabulation also, you will go with the dp, so which is of length n, right? Yes or no? Yes or no, buddy?
Yes. Yes.
Yeah.
Here also you will go with the length of n. Okay, so that is clear. Now you need to define the base results. It's a bottom up, right? So you need to define the base result. So it means base result means what are the base cases you return on memoization, which are going to be base results in tabulation. What are the base cases you return on memoization?
Index equal to 0 and index equal to 1.
Yes, right. So it means index 0 means dp of 0, so which is going to be nums of 0. And dp of 1, index 1 means dp of 1, so which is going to be max of nums of 0 comma nums of 1. Perfect, na? You solve two base cases, na? Now where do you want to start? So you must and should start from index 2, right?
2. Yes.
Yes.
And this index go till less than n is the nums dot length, so your index plus. Now tell me, again same case, right? Again same case. So one is integer include, so which is going to, if you are including means you will take the current index. Okay, so nums of current index plus where is the result will be present. You already solved, right? So if I equal 2 means you are reaching 2 means you already solved previous 0 and 1. So dp of index minus 2, correct? Yes or nobody?
Yes.
So dp of index minus 2. So similarly, exclude means you will take the nums of index.
We will not take that, right?
Yeah.
We'll directly go for.
Perfect. Yeah. So exclude means we don't consider the current index. Perfect. So we don't consider current index. Definitely, you will move on to its previous minus 1. So which is index minus 1. Now it is going to be dp of index, which is equal to max of these two. So include or exclude. So whichever it is, you will just include or exclude. So whichever it is, so you will just consider that, and finally you will return dp of n minus 1. Perfect, na? So it means this is what you are trying to do. So let me do one thing. So I'm not doing anything. So let me park this part. Okay, so I'll comment it later. So what I'm trying to do, first thing, you defined a dp. Okay, fine. So you will try to make you will try to make subproblem results. So which is from base results of a recursive solution. So which is going to be nums of 0 and dp of 1. So which is going to be dp of 1. So which is going to be base result again. You just take it. Now what is our job now? So you are trying to start from index 2. So index less than nums dot length and index plus plus. So here n is nums dot length. Again, what is your job? So you are trying to copy these two values. And now if you closely see, earlier what we did, so we are trying both top down, right? So you don't know subproblem result, so that you try to solve it. But in this case, you already, it is a bottom up, right? So that you know subproblem results already. So you just consider it. So dp of index minus 2. When you are at index 2 means you solve 0 and 1. So you already get 0th value. It means you already get 0th value. Similarly, it is going to be subproblem result dp of index minus 1. Okay, if you closely see, this is how it is, right? So you already know the subproblem result, so you don't need to solve it again. So just take the dp here and take this changing state. That's it. So this is how it is. You just copy it, change it. So you don't need to write the dp of index minus 2 also. Copy it and change it. Then finally, this is your dp of index, right? This is your dp of index. And finally, you will try to return dp of nums of index length minus 1. Okay, so that's it. You can delete it. Just do copy paste and change wherever it is required. You don't need to apply brain for tabulation. Never ever try to apply brain for tabulation. Or what I mean to say is, never ever try to solve tabulation directly. So it can't be possible. So what it is trying to say, array index out of bounds exception. The only problem is if nums dot length, which is equal to 1, return nums of 0. Okay, so yeah, so it is giving length as 1, and we try to figure out for 2, so that's why it was giving an issue. So let me submit. Now
Shouldn't actually do they will care about like what approach you are thinking of, or we directly go for tabulation if we
they
know
care
the answer?
about you come up with you have to end at the end. You should come up with tabulation only for sure, because if you give the memoization, you might be saying that what if my n value is 10 power 9, then the space is going to be 10 to the power 9, right? Stack space. Correct. Space. So that may lead to, even you go with memoization, you will solve at once, right? So then we will finally convert into tabulation. So but they are 95% they are happy with the memoization. Very few cases when kind of Google kind of interviews, then they'll expect you to write somewhat more optimal tabulation. You should derive it to tabulation. Now tell me, can we further optimize this? Can we further optimize this?
No need to write include and exclude values.
Why, man?
We can directly write those two into one.
That is not the improvement in the space, right? That is just a, that is not the improvement in the space, right? That is just a way of coding, right? It's a coding standard. What do you say? It's a code review comment. That's not a improvement in your algorithm. After
Instead of taking array,
tabulation,
we
after
can take
tabulation,
two
what
variables.
I said after tabulation, you should think about, can we apply, what do you say, space optimization on tabulation. Right now, the space of this is dp big O of n, right? For dp, can we optimize that?
Yeah, instead of taking the DP array, we can take just two variables and
Why? Why only two?
for the store the base cases, to store the DP0 and DP1.
So if you closely see, your DP problem is always your current problem is always depending on previous two problems, right? Yes or no, buddy?
Correct.
Index minus 1 and index minus 2. So it's not worried about previous to previous, right? So it's only considering about last two problems. So that's why you don't need to worry about considering whole memory. So what I do, so int n1. So what it is representing? So and I'll take int n2. Okay.
The
So
first subproblem and second subproblem.
yeah, so note take somewhat like note. So n1, which is nothing but what, buddy? Index minus 2, right? Yes or no? If you are at
Okay.
Yes.
2, it is at index minus 2, right? So this is more generally you tend to get confused here. So n2 means it is going to be index minus 1, right? So it means you are considering only 0th index here, but in this case you are considering both indexes 0 and 1. So it means n2 is representing last with two indexes, what is the best value you get. N1 is representing with one index, what is the best value you get. So which is more important, so don't get confused. Okay, so it means what you should do now, whenever you see index minus 2, replace with n1. Whenever you see index minus 1, replace with n2. And that's it. Now you will get the temp, which is going to be math dot, so whatever logic you write here. Yeah. Okay, so you got the result. Now in the next this temp is going to be n2 and n1 is going to be n2, right? So this you already know, right? Temp is going to be n2. Then for the next problem, previous result is equal to current result, so that you already stored in n2, so that you will get, hope you understood line 15 and 16, right? Correct, buddy?
Yes.
Akash? Akash on mute, okay. So now what do you want to return from 19?
And 2.
n2?
Yes.
Yeah, n2 should be solving it. Yes, temp will always hold whichever is maximum. So definitely n2 will definitely hold it. Perfect.
Anyways, we are assigning the temp to again n2, right? So
Yes,
the final result will be at n2.
that's it. So that's how it is. Now with this context, right, you must be able to solve. The first three problems in the exercises. So please solve these first three problems. Let me stop. Okay, so tomorrow I'll talk about this DP on greedy with Fibonacci pattern. Then we will move on to the next pattern on DP. Okay, so thanks for your time. See you tomorrow.
Thank you, Srinu.